So welcome to this lecture, and today we will be discussing the two-sample t-test, what it is and how to solve problems based on it. So the two-sample t-test is used when two random samples are drawn independently from a given population, and this test determines whether the difference there are actually two populations. So from two populations, and this test determines whether the difference between the means of these two populations is statistically significant. So there are two populations, we draw two random samples from them. So let mu1 and mu2 be the two population means, and sigma 1 and sigma 2 be the standard deviations. Let d0 be the hypothesized difference between mu1 and mu2, that is what is mentioned in the hypothesis. And x1 bar minus x2 bar is the difference between the sample means. I'm just going through the different notations. N1 and N2 are the sample means. Now you have the hypothesis, that is lower tail test H0, the null hypothesis will be mu1 minus mu2 greater than or equal to D. The alternate hypothesis will be mu1 minus mu2 less than D. Upper tail test, the null hypothesis is mu1 minus mu2 less than or equal to D. The alternate hypothesis is mu1 minus mu2 greater than D. And the two-tail test is mu1 minus mu2 equal to D, and the alternate hypothesis is mu1 minus mu2 not equal to D. So we will discuss the various parameters for each. The test statistic for all the three is given by T, which is x1 bar minus x2 bar minus D by root s1 squared by n1 plus s2 squared by n2. The degree of freedom is again the same for everything, and that is s1 squared by n1 squared plus s2 squared by n2 squared the whole squared by n1 minus 1, 1 by n1 minus 1, s1 squared by n1 the whole squared plus 1 by n2 minus 1, s2 squared by n2 the whole squared. The rejection rule, using the p-value, we reject H0 if p-value less than or equal to alpha in all the three cases. And using the critical value for the lower tail test, we reject H0 if t less than or equal to minus t alpha. For the upper tail test, we reject H0 if t greater than or equal to t alpha. And for the two-tail test, we reject H0 if t less than or equal to minus t alpha by 2 or t greater than or equal to t alpha by 2. So coming to problems. Problem 1. Consider the following. H0 is mu1 minus mu2 equal to 0. HA, the alternate hypothesis, is mu1 minus mu2 not equal to 0. So two random samples are taken from the two populations. You have sample 1, sample 2. You are given N1, N2, x1 bar, x2 bar, and S1 and S2. These are the sample size, mean, and standard deviation for the two samples taken from the two populations. So the first question is evaluate the test statistic. So that is given by t equal to x1 bar minus x2 bar minus d by root s1 squared by n1 plus s2 squared by n2. What is d here? D is 0 here. So substituting, you get it as 2.80. Next, calculate the degrees of freedom. So degree of freedom is given by this formula s1 squared by n1 plus s2 squared by n2 the whole squared by 1 by n1 minus 1, s1 squared by n1 the whole squared plus 1 by n2 minus 1, s2 squared by n2 the whole squared. Substitute and you get degree of freedom as 65.64, and since we are using the table, what will we take degree of freedom as 64. Now what is the p-value? The p-value, you look at the t distribution table, you look at degree of freedom 64 and test statistic as 2.18. So this is the t distribution table. So we will look at 65 and 2.18. So if we were to just zoom this a little, we have degree of freedom 65 and 2.18. So that basically lies between these two values. So between 0.05 and 0.025. I'm just going to zoom it a little more. It's between 0.05 and 0.025. So coming back to the question, your 2.18 lies between 0.01 and 0.025, and since it is a two-tail test, the p-value will lie between 2 into 0.01 into 2 into 0.025. So you need to remember this: when it is a two-tailed test, you will multiply it by 2. So p-value lies between 0.02 and 0.05. Now at alpha equal to 0.05, what is your conclusion? The p-value is less than alpha, so we reject h0. So what is h0? Mu1 minus mu2 not equal to 0. So this implies mu1 not equal to mu2. What is the rejection rule using the critical value? Now using the critical value, t alpha by 2. When do you reject using the critical value? If t greater than or equal to t alpha by 2. So first we calculate t alpha by 2. Alpha, what is alpha? 0.05. So this is 0.025. And again, if you look at t 0.025 with degree of freedom 65. So you go up to 65 and t 0.025. So you will get it as 1.997 here. You can use the t distribution table which is available online, and you get this as t equal to 1.997, and 2.18, which is a test statistics, is greater than or equal to t alpha by 2. So we reject h0, and what is h0? Mu1 not equal to mu2. So that brings us to the end of this question, and if you can use it using the calculator, it will save your time. Question 2. Coming to question 2, consider the following hypothesis test. The null hypothesis h0 is mu1 minus mu2 less than or equal to 0. Alternate hypothesis is mu1 minus mu2 greater than 0. Two independent samples are taken from the two populations. So again you have sample 1, sample 2, n1, n2, x1 bar, x2 bar, s1 and s2. So we evaluate the test statistic. Again we use what is the formula which we had just seen. T equal to x1 bar minus x2 bar minus d by root s1 squared by n1 plus s2 squared by n2. Again d is 0 here. So substituting the values, you get t as 1.87. Next question will be find the degree of freedom. So again, what is the formula for degree of freedom? S1 squared by n1 plus s2 squared by n2 the whole squared by 1 by n1 minus 1 s1 squared by n1 the whole squared plus 1 by n2 minus 1 s2 squared by n2 the whole squared. Substituting, you get 25.43, which is approximately equal to what? 25. Now the next part is find the range of the p-value. Again, you look at the p distribution table and you look at t distribution table, look at degree of freedom 25 and the test statistic is 1.87. So if degree of freedom is 25, that is 25 here, test statistics is 1.87. I'm just going to zoom it a little. So corresponding to 25, test statistic is 1.87. So it lies basically between 1.711 and 2.064. So it lies between 0.025 and 0.05. So we have the range will by p-value will lie between 0.025 and 0.05. And will we multiply by 2 here? No, because there is, why do we not do that? Because it's a one-tail test. Now at alpha equal to 0.05, what is your conclusion? The p-value is less than alpha, so we reject h0. And what is h0? Mu1 minus mu2 greater than 0. h0 is mu1 minus mu2 is less than or equal to 0. So mu1 minus mu2 is not less than or equal to 0. That means it is greater than 0. What is the rejection rule using the critical value? Now we reject h0 if t greater than or equal to t alpha. So again we look at t 0.05 corresponding to 25 degrees of freedom. So I'm going back to the table. We have t25 corresponding to 0.05, you get 1.708. So we have that 1.708, the test statistic is greater 1.87, it's greater than 1.708. So what do? We reject h0. And what is h0? Mu1 minus mu2 less than or equal to 0. So mu1 minus mu2 is greater than 0. So we have come to the end of this lesson. We have learned what is a t distribution and learned how to solve problems for a two-tailed test. Basically, we have worked on two-tailed test here. So thank you.